which is nothing but here b by a, or else y equals to b by a into x, where b by a is the slope here. So you can say that here the slope which can be determined by the ratio of these two amplitudes. A and B are the amplitudes along the x as well as the y. So the amplitudes, if the amplitudes are equal, you can say that y equals to x. So for this case here, which is going to be inclined at an angle of 45 degrees to these axes. So condition is that if phase constant is differ by 5 by 2, 90 degrees here, delta 1 minus delta 2 is 90 degrees. In this case, how these equations you are going to write here? Let us consider that x equals to a cos omega t plus delta 1, or y equals to a b cos omega t plus delta 2. Let us write it down here. These are going to be differed by a phase is 90 degrees, means delta 2 may be written as delta 1 minus 92. Is it clear? From this equation only, delta 2 equals to, you can write it down, minus delta 1 minus 90 degrees is 5 by 2. Substituting here, a cos, b cos omega t plus delta 1 minus 92. So that can gives you here sin theta. Cos 90 plus theta is nothing but a sin theta. Is it clear now? Cos 90 plus theta. So that is going to be writing here. B sin theta value is omega t plus delta 1. So if you are going to be squaring the above equation, that is from x by a is this one. Which one? This one. Squaring this x by a whole square equals to x square by a square equals to cos square omega t plus delta 1. Similarly, y by b whole square equals to that is from this equation. So that here you can have y square by b square, not this one. This is, you have to consider this equation. Which equation? This equation. Okay. This is not cos, sin square. Y by b whole square equals to sin square this. By adding this x square by a square plus y square by b square is 1. Why? Because of cos square theta plus sin square theta is 1. Is it clear? You can correct in your textbook. समझ में आ रहे? हेलो.
यस सर.
Yes, sir.
टेक्स्ट बुक में करेक्ट कीजिए, यही इक्वेशन से आता है. So not to buy this. Why? Because of you have been applied a condition which are going to be differed by a 90 degrees. Then the equation becomes this one from this only. By adding these two terms, these two, left hand side, x square by a square plus y square by b square equals to, what is the value? Cos square theta plus this is sin square theta. That is 1. Okay. So here, if x square by a square
Sir.
as well as, yeah, tell me.
Sir, here this is sin square omega t plus delta. And
Yeah.
this is cos square omega t plus delta 1.
Yeah, either delta 1 equals to delta t equals to delta. You need not to worry.
Okay, so it is almost
Here also,
equal.
here also delta 1.
Okay, fine.
Okay.
Yeah.
Yeah, so many mistakes are there. You can correct. So here, when do you get the x maximum value? X, that means the displacement value should be maximum when y value equals to 0. Then you will get the maximum is, the displacement is x maximum. So that here in this condition, you need to say that this is the path of the particle where then the amplitudes, that means x square by a square plus y square by b square equals to 1. that is going to be tracing out an elliptical orbit. That means the path should be elliptical. Or else if A equals to B means, in this equation, x square plus y square equals to A square. Why? Because of you have to substitute. If A equals to B, then the motion should be circular. Here this is ellipse. The motion is ellipse. Here the motion is circle. Okay. That means the path with is where the two simple harmonic motions which are to be acting upon a particle, those are perpendicular to each other when the displacements, square of the displacement's value which is equals to the square of the amplitude. For that condition, the path of the particle is circle, and if the value should be 1, the path should be elliptical. So that here below, for different combinations, they have been tracing out the straight line, elliptical orbit. This is for 5/2, circle is there, and opposite clockwise is there, anti-clockwise is there. Okay. The symbol, 8 symbol is also there. The symbol 8. Is it clear? So different shapes which are going to be here, the particle is going to be tracing out here. The thing is that here, when you are going to be changing the frequencies, the ratio, that means here the ratio is given out here. Along the x-axis, 2 is their frequency, and y-axis only 1 frequency is there. So that that tracing out of the parabola, elliptical orbit, different 8 shapes is also going to be coming out here. You can easily observe from the CRO by using a cathode ray oscilloscope. When you're connecting to the circuit here, by changing the frequency, you may observe these figures on CRO. So many figures are there. So you can see this, the block diagram of cathode ray oscilloscope. The one which is going to be indicating here. So this one, this is a fluorescent screen is there. And here an oscillator, audio oscillator is there. And here X and Y plates. This is X plate and this is the Y plate, which is to be given connecting to this. So that by changing the X and Y, that means along the X and as well as the Y. So here the electron which is going to be deflecting by each of the two electric fields which are right angles to each other. That means the X plate as well as the Y plates. So the two simple harmonic motions which can be applied to the X plate as well as the Y plate here. So that you are going to be observe the how the electron can be tracing out for different patterns that may be observed in this above figures. Okay, directly you can able to observe here. So this may be asked as an essay question, but you need to work out here. Only shortcut method is given out here. But in unified physics, to go through the unified physics, there you can able to find out the here very lengthy process is there. You can easily find out each and every step clearly explained in unified physics. Then I just want.
Sir, what is this unified physics?
Unified physics is that is for regular universities that the students which you are going to be following through the unified. Unified is better for physics students.
Okay, it's a book name, sir. Unified
Yeah,
physics.
Textbook.
That we can get from the regular bookshop.
Yes.
Okay, fine, sir.
What I am going to share you, is it clear to you? Is it visible to you?
Yes, sir.
Yes, sir.
I am sharing the PPT. You can follow this. Entire oscillators total.
Please share, sir.
Yeah, I'm sharing now. Is it visible to you? दिख रहा है कि नहीं?
दिख रहा है सर।
PPT.
पीपीटी दिखाई दे रहा है।
Yeah.
ऑसिलेटर्स ना, सम सिंबल्स,
Yes.
कैपेसिटर।
Yes. Okay. So we can go for the oscillators here. So what in this you need to know about the simple harmonic oscillator. This can covers the entire first unit. Entire first unit, not first chapter. Okay.
यस सर।
What I am going to discuss, that should be available in your textbook, Open University textbook. In detail, I am going to be giving to you. So in this simple harmonic oscillator, DHO damped harmonic oscillator, there are 3 different conditions are there: under damped, over damped, critically damped, expected essay question, and energy decay, relaxation time, and later on forced oscillator. So, and the resonance coupled oscillations, harmonic waves, and the wave equation. Okay. So, what is a periodic or harmonic motion? So, any motion which repeats itself, after regular interval, which is called periodic or harmonic motion. So, and the time interval after which the motion is going to be repeated. Where do you observe this periodic motion? In our regular daily life. Periodic. What is periodic? Same thing which is going to be repeated.
our AC, this current, AC current.
AC current, sine wave, which is going to be periodically, which is generating. Is it clear or not? Okay. 0 to pi, pi to 2 pi. Again from 2 pi, the sine wave, positive half cycle, negative half cycle. Getting my point?
Yes, sir.
To show you, my boy. Sorry. Positive half cycle, negative half cycle. Positive half cycle, negative half cycle. Getting? Positive half cycle, negative half cycle. Positive half cycle, negative half cycle. Where it is going to be 0 to pi, 2 pi, 3 pi, 4 pi. Okay, 0 to 2 pi. Again from 2 pi to 4 pi. Repeatedly, which is going to be takes place. Is it clear? And also in music, sari, gama, pada, ni. Again, sa. Is it clear?
Yes, sir.
So, any motion which repeats itself after regular interval of time, that is called periodic or harmonic. And that is the position and the velocity of the moving body is same. Position as well as the velocity of the moving body, which is same, is called, it's a time period. So, you can see here. Take right? What is first figure?
Yes.
Solar system and moon.
Yeah. Moon is rotating toward the earth, around the earth. Earth is rotating around the sun. Is it clear? Periodically. So for the periodic motion, you can able to observe that. Here a simple pendulum is there. Periodically, regular interval of time, the pendulum is going to be oscillating with respect to their equilibrium position. Next, what is that? Third one. Third one ఏంటండి?
Piston.
Yeah. Okay. That is electric motor piston is there. Moving up and down. So this is oscillatory or vibratory. In the case of periodic motion, the body moves back and forth repeatedly about the fixed point here. That is called motion. It is said to be oscillatory or vibratory. So simple harmonic motion. So in this simple harmonic motion, an oscillatory body is said to be executing simple harmonic motion if the magnitude of the forces acting, capital F, which is acting on any body, which is directly proportional to the magnitude of the displacement. Yesterday, we already discussed F is proportional to X. Okay. And the mean position, the displacement from its mean position, and the force. What type of force it is? Restoring force. Why? Because if here, in this pendulum, second figure, you are applying such a force, sectional force on the bob here. The bob which is going to be moving, that means the pendulum is going to be moving from the equilibrium position into the maximum position, maximum displacement. Again, the pendulum is not moving in forward direction. When the pendulum is going to be reaching at the maximum position, the pendulum is trying back to get its equilibrium position, original position. That means it is trying to get back its the same position. So that the force which is going to be acting in opposite direction. So that force is a restoring force here. So which is always directed towards the mean position. Next. That is called F is proportional to minus X. Next. Simple harmonic oscillator, which is depend on the motion of any oscillatory particle, which is acted upon by a restoring force. So which is directly proportional to the displacement, but it is opposite in the direction. So you can see here pendulum which is going to be oscillating. So what are the characteristics of the SHM, simple harmonic motion? The motion is periodic. The motion is along a straight line about the mean position. Acceleration is proportional to the displacement. Acceleration is directed toward the mean or equilibrium position. So if you want to calculate the equation for a SHO, let us consider that a block of mass is kept small m, which is executing simple harmonic motion about the equilibrium position O, the x-axis, along the x-axis. So you can find out that a figure which is going to be showing, that means here the spring is to be considered here. One end is rigidly fixed. Other end, small m mass, which is going to be attaching to the spring here. Okay. Here the force is 0. No force is going to be acting upon the spring. Okay. Second figure. What is the second figure here? Such a force, that means the weight is going to be attached here. The spring is going to be elongated. Is it clear? The spring is stretched here. Okay. So here the elongation is going to be takes place from its equilibrium position. How much? Here to there. But after reaching this position, there is a restoring force which is going to be acting in opposite direction. Could you able to see this? Second figure. Figure समझ में आ रहा है कि नहीं? Hello.
Yes, sir.
Yes, sir.
Yeah, you can see here. This is the C. This is the X. How much the block which is going to be displaced? X. Positive X. Positive X. But the force which is a restoring force. Next. Again, such a force which is to be acting. That means here compressed. When the spring is going to be compressed here. Compressed here. So that negative displacement. This is the main position, equilibrium position. And here, which is in opposite direction, the spring is going to be stretched by such a displacement negative X. So that here the force which is to be acting in this direction. This force is a restoring force. Is it clear? I think so. So many times you have been done this experiment in your daily life. Yeah. So by the definition, the force under which the particle is going to be oscillating here, which is proportional to here displacement directed toward the mean position. So here a positive X. Here it is a negative x. But every case, there is a restoring force which is to be acting upon this. That means F is proportional to negative x. So here let x be the displacement of the block from O at any instant. The force acting upon the block is given by F is proportional to negative x or F equals to minus kx, where k is the spring constant or proportionality constant. Negative sign which is going to be using here. The force is opposing the displacement. Next. According to the Newton's second law, the force which is always proportional to the acceleration here. That means already told you F equals to ma. A is the d square x by dt square. But F equals to minus kx. So by equating these terms, m into d square x by dt square minus kx, or else by adding, and k by m equals to 0, or k by m is nothing but omega square x. Okay, this is the differential equation of SHM. Next, what is the solution here? So if you want to calculate the A value, let you find out the what is the dx by dt value. So d square by dt square equals to d by dt of dx by dt or dv by dt. Okay, what is dx by dt? You can copy this. What is dx by dt, Andy? V.
Velocity.
Yeah, velocity. That is dv by dt. Okay, this equation. Again, dv by dt can be written as dv by dx of dx by dt. Can you write like this? By cancelling dx, same thing will be remain, na?
Yes, sir.
Yeah. So dx, then dx by dt is v and dv by dx. So d square by dt square can be written as v of dv by dx. Okay. So substituting the value of d square by dx, dt square in equation 1, where it is here. So v of dv by dx plus omega square x equals to 0, or you can see here v of dv that is equals to minus omega square x into dx. Equation 2 समझ में आए बाबू? सेकंड इक्वेशन అర్థమైందో లేదో చెప్పాలి.
ఎస్ సార్, అది ఒమేగా స్క్వేర్
Sir.
నెగిటివ్ లా అయింది, తర్వాత డిఎక్స్ వెళ్ళినప్పుడు మల్టిప్లికేషన్ అయింది.
ఎస్ మనకి తక్కువ టైం ఉంది కాబట్టి ఈ 1 hour లోనే మనం యూనిట్ లేపాలి.
అవును సార్. సార్ ఈ పీడిఎఫ్ కొంచెం మా చార్ట్ లో పంపిస్తారా సార్?
ఈ చార్ట్ కాదు కానీ మీరు ఒక గ్రూప్ క్రియేట్ చేసి నన్ను యాడ్ చేయండి, మీకు అందులో పంపిస్తాం. వాట్సాప్
ఓకే.
బిఆర్ అంబేద్కర్ సెకండ్ సెమ్ గ్రూప్ అని పెట్టండి, ఇంగ్లీష్ మీడియం. సో దట్ ఇన్ దట్ ఓన్లీ ఐ కెన్ షేర్ యూ ఎవ్రీ నోట్స్ రిలేటెడ్ టు సెకండ్ సెమ్ సంబంధించి.
ఓకే సార్, షూర్ సార్.
రైట్. సో by integrating this x dx formula x square by 2. Similarly, v dv means v square by 2. By integrating this is second equation. And omega square, that is again x dx is there, x square by 2 plus constant c1. So where c1 is the constant of integration, which can be applied, but you can obtain by applying the boundary conditions. If x equals to a, that is the velocity of the particle is 0. Here x equals to a means the velocity of the particle. X, what is x here? Displacement of the particle. What is a? Acceleration. If both are same, the velocity should be 0. So by applying this condition, v value is 0, substitute here. V value 0 minus omega square. What is x value? X equals to a. So a square by 2 plus c1. So you can easily getting here c1 value is omega square a square by 2. Substitute in above equation. So that v square by 2, same equation. V square by 2 equals to minus omega square x square by 2 plus what is c1 value? This one. Omega square a square by 2. So omega square by 2 is a constant. If you are going to be commoning here, that means a square minus x square. Is it clear? Actually minus x square plus a square. That is going to be writing here a square minus x square. బాబు అర్థమవుతుందా?
ఎస్ సార్.
Yes, sir.
Yeah, v square equals to divided by 2 ఉంది కాబట్టి మనం both sides you can cancel the 2 here. V square equals to omega square into a square minus x square, or v equals to omega into square root of omega into omega square అంటే square root లో మనకి cancel అవుతుంది కాబట్టి square root of a square minus x square. This is the equation number 2. So that you have been find out the v value. V value is omega into square root of a square minus x square. ఓకే సార్, మరి ఇదంతా మీరు రెగ్యులర్ దానికి సంబంధించి చెప్తున్నారంటే ఏదర్ యూ కెన్ గో ఫర్ ది రెగ్యులర్ ఆర్ ఓపెన్ యూనివర్సిటీ, వాట్ ఎవర్ ఇట్ మే బి, డిస్టెన్స్ లో మనం ఎట్లా పోయినా కూడా సబ్జెక్ట్ ఈజ్ సేమ్. ఓకే, కరెక్షన్ చేసేది మేమే కాబట్టి యూ నో నాట్ టు వరీ. సో v equals to dx by dt, and you got the v value is omega into square root of a square minus x square. So equation 3 can be written as 3 ని ఎట్లా రాసుకోవచ్చండి? dx by dt is nothing but a v. Okay, rate of change of displacement, that is going to be v of square root of a square minus x square. So dx by left hand side రాసుకున్నాం మనం ఇక్కడ omega into dt. So integrate this with respect to x equals to a sin theta. dx ఏమవుతుందండి? a cos theta, sin theta is cos theta into d theta. Substitute there. So dx value is a cos theta d theta, square root of a square minus, what is x? What is x? X is a sin theta. Substituted here in place of this a square sin square theta, which is equals to omega into dt. You need to do the practice if you want to understand, if you want to get the knowledge by the physics subject, you need to do the practice. Without practice, you cannot able to get this all these steps. You cannot able to remember all this. You need to do the practice. Practice makes perfection. That's why I'm going to be repeating here. If you are a better mathematician, you can easily understand the physics subject. మ్యాథమెటిక్స్ సబ్జెక్ట్ లేకుండా ఫిజిక్స్ అర్థం కావాలంటే అర్థం కాదు 100%. సో ఏ కాస్ థీటా డి థీటా బై వాట్ ఇస్ దిస్ అండి? ఇది ఎట్లా రాసినాడండి? ఏ స్క్వేర్ కామన్ తీసినాడు, 1 మైనస్ సైన్ స్క్వేర్ థీటా. 1 మైనస్ సైన్ స్క్వేర్ థీటా ఈజ్ కాస్ స్క్వేర్ థీటా. ఏ స్క్వేర్ కాస్ స్క్వేర్ థీటా థీటా by removing the square root a cos theta. Okay, that is written. So here a cos theta get cancelled. Remaining is dt. d theta equals to omega into dt. That is the equation number 4. Integrating the above equation, when theta equals to omega t plus phi, phi is a constant. Okay, so d theta equals to omega into dt. That's it. So theta value is omega t plus phi. So now the displacement, you know pretty well, x equals to a sin omega t plus phi. In our textbook, a cos omega t plus phi. Is it clear? No need to worry. Both are same, either cos or sin. So the displacement of particle at any instant, this can gives you x equals to a sin omega t plus phi. What is the value here? Why do you written here? Again, I am going to show here. X value, you got the x value. X values a sin theta. What is theta? This one. Is it clear now? Reverse we are doing. Okay, so you calculated, sir, why do we choose displacement is x equals to a cos omega t plus delta or a sin omega t plus phi? Because of the above equation, v value is dx by dt, that is here, which you have been considered. From this only you have been calculated the displacement. Getting my point? From the A value, you calculated V. From the V value, you calculated X. Reverse we are getting. అర్థమవుతుందండి? టెక్స్ట్ బుక్ లో డైరెక్ట్ x ఈక్వల్స్ టు ఏ కాస్ ఒమేగా టీ ప్లస్ డెల్టా అన్నాడు. మనం ఏం చేసినా ఇక్కడ రివర్స్. ఏ వాల్యూ అకార్డింగ్ టు ది న్యూటన్ సెకండ్ లా m into d square x by dt square. From that equation, we have been calculated by applying the limits, by integrating the equations. You calculated x is a sin omega t plus phi. समझ में आ रहा है? అర్థమవుతుందా బాబు? No sounds.
sir. And this, sir.
Yes, sir.
Okay, yeah. So here then y equals to a sin omega t plus phi. Motion along y direction. Okay. Next, what are the characteristics? So most important. So derive the equation for the simple harmonic motion and mention their characteristics. That is the essay question. Either in a regular degree or open degree, whatever it may be. So characteristics. First is the displacement of a particle, which is executing a simple harmonic motion. X equals to a sin omega t plus phi. The maximum displacement from the mean position is called, that is called amplitude. So amplitude is in above equation small a. Next, velocity. Velocity, you know that dx by dt. So this is the x value, a sin omega t plus phi. By differentiating this equation, omega a into sin is sin theta is cos theta. Cos. So omega, what is this one? That can be writing here omega into square root of a square minus x square. Sorry, ఈ ఈక్వేషన్ ఎట్లా వచ్చిందంటే ముందు చేసినాం కదండి. v ఈక్వల్స్ టు దిస్. ఎక్కడ? ఇదిగో ఇక్కడ. ఇది ఈక్వేషన్. v ఈక్వల్స్ టు ఇది వచ్చింది కదా మనకు ఆల్రెడీ డెరివేషన్ లో. సేమ్ అలా చేయట్లేదు, మరలా చేయట్లేదు. సేమ్ థింగ్ ఐఎమ్ రైటింగ్ హియర్. So v equals to omega into square root of a square minus x square. So here at mean position, if x equals to 0, omega a. Is it clear? Velocity should be maximum. At mean position, okay? At mean position, the velocity is maximum. So where the velocity should 0? At extreme position. Okay. Next, periodic. So the time taken to complete one oscillation is called periodic time. That is capital T when small t is increased by 2 pi by omega. So x equals to a sin omega into t plus 2 pi by omega plus 5. So that is omega t and 2 pi plus 5. That is nothing but a sin omega t plus 5. Yesterday class is cos. Here is sin. So the time which is the displacement which is going to be repeated by 2 pi by omega. So this is called periodic time. So 2 pi by omega and 2 pi by what is omega? Omega value is in previous we have been calculated. Substitute here d square x by dt square by x omega value. So 2 pi into x by d square x by dt square, which is nothing but a 2 pi into what is x? X is the displacement. D square x by dt square is nothing but a acceleration. Capital T value. Next, frequency. The number of oscillations per second is nothing but a frequency, which is denoted by small n or nu. Nu, not v. Nu. So n or mu equals to 1 by t. So t is a 2 pi by omega, or 1 by t is omega by 2 pi. So what is omega and the root k by 1 by 2 pi into root k by. Next, phase. So the angle omega t plus phi is called phase of vibration. And here epoch, the value of phase when t equals to 0. When t equals to 0 is called phase or epoch. So phi is epoch. Next. So this is another essay question. So that sends our essay question, which is a damped harmonic oscillator. So wait a minute. Damped harmonic oscillator. You can see here. Damped harmonic oscillator. What you are going to observe here? A spring is to be considered, and here you can see that one end of the spring which is attached to the rigid, other end is such a mass is going to be hanging, so that the spring is going to be doing the here vibrations. Vertically it is going to be doing the vibrations here. So you can see here, when the vibrations are going to be 0, it is extreme. The displacement is maximum. Slowly the displacement is going to be with respect to time. It is decreasing here. Could you able to observe the figure here? Kanpistundandi figure?
Yes,
Yes,
sir.
sir.
Damped harmonic oscillator lo etla untayi? Vibrations gradually decreasing with respect to time. You can see. So the best example which has given out here, spring, which is attaching such a mass, so that how these oscillations are gradually, which is decreasing with respect to time. So we can go for this. Other one. See here. See, a scale, meter scale is there, which is attaching to one end, other end such a mass by applying such a force on it. Slowly, with respect to the mean position, green line is the mean position. How these oscillations are gradually decreasing. Next, expression for the periodic and amplitude of damped harmonic oscillator. So, the damped harmonic oscillator, which can have 3 different categories. One is that restoring force, which is proportional to the displacement. Previously, in simple harmonic motion also we have been discussed that. That value is F equals to minus X. F is proportional to minus X, or else F equals to minus Kx, where K is a spring constant or proportionality or force constant. Next, frictional force. Okay. Why these oscillations are deading out here? Can you tell me anyone please? Why these are going to be 0? Cheppali.
Due to gravitational force, this friction we can say.
No. No. Next. Anybody else?
After stopping an oscillation, it might be come under the 0.
Why? Why?
Oh,
You can see this spring is going to be doing the oscillations. Why
yes,
it
sir.
is going to be dead?
After stopping the oscillation?
We are not going to be stopping. The spring is going to be doing the oscillations. But
Because
it has to do the continuous, na?
because gravitational force is there and it is reducing the velocity.
No. There are here where the what do you say here, springy, which is going to be attached in which media? Air. Okay, getting my point? In air only, here there is some particles or molecules which are going to be resides in air. Due to the air, some particles which are going to be here, what do you say here? Frictional forces. Okay, some of the particles which are to be stopping their oscillations or vibrations. So that force which is nothing but a frictional force. In a medium you have been considered. That's why here air molecules which are stopping these oscillations.
Yes.
That's why which are going to be deading out. Okay.
And in vacuum it will be continue.
Yes.
Okay,
That's
sir.
right. That's why whenever you are going to be measure such a weight here, there only a closed chamber of what do you say, weighing machine is to be placed. Then it can give you accurate value. Or else if it is open, there some weight changes, variations is going to be takes place. So here other force is that by the damped harmonic oscillator, the oscillations are going to be deading out, means here some of the frictional forces due to the air, those are going to be acting upon here. That means the frictional force, which is always proportional to the velocity, but it is also opposite. Restoring force is also opposite. Frictional force is also going to be opposite. So this may be written as minus small r, F value. This is also force, dx by dt. R is a frictional force per unit velocity. Since F equals to m into d square x by dt square, according to the Newton's second law, therefore the equation of motion of a particle, you can go through this. M equals to, sorry, F equals to this one. That is, one is that m into d square x by d square, which is equals to restoring force minus kx minus frictional force. Because of you are adding these, right hand side you are adding, but the thing is that both are in negative. That's why here minus kx is a restoring force and also frictional force. So simply you can write it down by taking this equation into left hand side, d square x by dt square plus m into d square x by dt square plus kx plus r into dx by dt equals to 0. Or else then it goes by dividing with m, d square x by dt square plus r by m into dx by dt plus k by m into x equals to 0. So d square x by dt square plus r by m, you can consider it as a 2b into dx by dt. You know pretty well what is k by m, omega square. Is it okay up to equation 1?
Yes, sir.
So where r by m is 2b and k by m is omega square. Next. Equation 1, differential equation of second degree, d square x by dt square plus 2b this. What is the solution for this? X equals to a e power alpha t. Why do you consider this equation? Why don't you consider x equals to a cos omega t plus 5? Why? Because of this is the oscillations are not periodically. These oscillations are the vibrations completely. After such a time, these are going to be deading out. So the decrease, which is going to be here representing here e power alpha t. Okay, e power means exponentially. One term is there, that alpha with respect to time t, the amplitude a is gradually decreasing. Okay, this is not written in your textbook. You need to go further. So where a and alpha are the arbitrary constants, differentiating equation 2 with respect to t. So that is nothing but here. What is it? X, a e power alpha t. What is dx by dt? A alpha e power alpha t. Again, d square x by dt square is a alpha square e power alpha t. Is it clear, Andy? Is it okay?
Yes, sir.
Next, substituting in equation 1. Here we are substituting which value? This value in this equation. So d square by dt square, d square x by dt square is a alpha square e power alpha t. And 2b into dx by dt is a e power alpha t. Omega square, what is x and d? This one. So everywhere a e power alpha t is a common factor. So that by commoning this, alpha square is there, 2b alpha is there, omega square. Next, the a e power alpha t is not equals to 0, but alpha square 2b alpha omega square equals to 0. This can gives you alpha equals to, okay, roots of this equation, ax square plus bx plus c equals to 0. అవునా కదా? అదే ఫార్ములా ఉందండి. ax square plus bx plus c equals to 0. The roots x equals to minus b plus or minus b square minus c square by 2a. Formula dena?
Yes, sir.
Yes,
Go for
sir.
that. Go for that. You can get two equations. One is that plus, another one is the minus. By substituting here in x, you will get the equation 3. You need to do the practice. Okay, time is very less. Where a and a2 are the arbitrary constants. So depending upon the value of b and omega, there are three cases. These are very, very important. Okay. In examination, the examiner is going to ask you out of these three cases, any one case, either a overdamping or a critical damping, other one is also. So we can go discuss it further. Overdamping. So when b square minus omega, b square is greater than the omega square. B square is greater than the omega square. In this case, b square minus omega square, square root of b square minus omega square is real, and which is less than the b. So that the powers here in this equation, equation 3, minus b square root of b square minus omega square and minus b square minus omega square. So in equation 3, both are negative here. Thus the displacement x value, this one, which consists of two terms, both dying off. Dying off means completely the oscillations will go 0.
0, ending.
Exponentially, which goes to 0 without performing any oscillations. Okay, this is the thing. So this is the case. You can see here, overdamping, without performing any oscillations. Is there any oscillations is going to be observed according to this time versus amplitude? Completely blue light, blue color line indicates no oscillations. Completely 0. Next. So the rate of decrease of displacement, which can gives you here the terms which reduces to 0. And in this case, the body once displaced to its equilibrium position quite slowly without performing any oscillations. You can see. Okay. Overdamping. See here. Where do you observe? समझ में आ रहा है जी? You can see over damping case, critical damping case, under damping case. Is it clear? Blue is under.
Sir, we can say overdamped is non-elastic item.
Yes. See here. Completely 0. It is not performing any oscillation. Later on critical. Only under damping condition only. Slowly, exponentially it is going to be 0. So this type of motion you can call it as a overdamped or deadbeat. So the motion which was given by the pendulum moving with a thick coil or a deadbeat moving in a coil galvanometer. Thick coil is there. Thick coil is to be considered. Thick coil means high viscosity. Okay. Whenever you considered a high viscosity, there only, if the pendulum is going to be oscillate, means it doesn't do any oscillations. Why? Because of viscosity is more. If less viscosity, it can do the oscillations. Next is the critical damping. So same equation is to be considered here. Equation 3. When b square equals to omega square. B square is equals to omega square means you need to say that
this is 0.
Yeah.
So minus b.
In this condition, here by substituting this b square equals to omega square, You can substitute here. Equation 3, which is going to be reduces to this one. No term is there. Okay, na? Here b square minus omega square. This term is 0. Substituting minus b. Let us assume that h and this one is. This is not a lecture class. This is only a counseling class. But I am giving a lecture. Okay. So substitute and write it down here. E power x into e power y means e power x plus y. The same thing. E power minus bt. A1 into e power ht. ప్రాక్టీస్ చేయాలండి. ప్రాక్టీస్ చేయకుండా మీకు రావాలంటే రాదు. Similarly, e power minus ht. So e power x means 1 plus x plus like this. Next, e power minus 6 is 1 minus x like this. So maths లో కంపల్సరీ మీకు ఫార్ములాస్ ఉంటాయి, మీరు చూసి రాసుకోండి. a1 తో మల్టిప్లై చేయండి. a1 here is there, here a2. Between plus is there. So a1 plus a2. And here next term is a1 minus a2 into ht. Okay. Let us consider that a1 plus a2 is p, a1 minus a2 is q, h into a1 minus a2 is q. చూసుకోవాలి. This is equation number 4. Let p is this, q is this. Next, same equation. X equals to e power minus bt into p plus qt. So this equation represents a possible for a solution. So in this equation, t increases, time increases, p plus qt is also going to be increases. But term e power minus b minus, that is going to be decreasing. So that is called here critical, red color. Okay. In graph, you can able to observe how the under damped condition, which is going to be seen here, gradually decrease. Next is under damped, less than omega. So let us, this is an imaginary part. Let us write in here minus square root of b square minus omega square is I into. Why? Because of here omega is greater than. That's why here omega is I. If it goes into square root, I square is minus 1. समझ में आ रहा है जी? If I goes there, side the square root, I square is minus 1. Minus 1 तो multiply చేయండి. Minus omega square minus into minus plus b square. That means b square minus omega square. Same thing. ఇదే ఈక్వేషన్ రాసి. మ్యాథ్స్ వస్తేనే ఫిజిక్స్ వస్తుంది, లేకపోతే రాదు. సో దిస్ టర్మ్ యూ కెన్ కాల్ ఇట్ యాజ్ ఎ బీటా. Beta is this, I is square root. Substitute here in equation 3. So by simplifying this, same thing. Previously, in critical damping, what you have done, the same thing which is repeated in under damping by using these conditions. So e power I beta, that is here ix ante e power ix means cos theta plus I sin theta. This is minus ante cos theta minus I sin theta. Substitute చేయండి. ఇక్కడ a sin phi అనండి, b sin phi. That can gives you, by simplifying this equation, you can have this one. So cos theta plus sin theta, cos theta sin theta plus cos theta, sin phi cos beta plus cos phi sin theta. Sin A cos B plus cos A sin B. That is sin A plus B. Sin A plus B. Note it down. So substituting, you will get this one. So this equation which is representing here a simple harmonic motion. But amplitude which is gradually decreasing with a term here, e power minus bt. So t equals to 2 pi by omega place of omega. What is that? Omega square minus bt. This is exponentially here decreasing the amplitude, a term which is going to be decreasing. That is, a term is e power minus b. So which can varies between the positive to negative. That means +1 to -1. So the decay means decreasing of the amplitude depends upon the damping coefficient. Damping coefficient is a p, and which is called underdamped motion. This one. So underdamped, gradually the amplitude is decreasing. This is the condition. Gradually with respect to time. Okay. So power dissipation is not there in this for you. Relaxation time. Only 2 minutes is there. Relaxation time, which is defined as the time taken for the total mechanical energy to decay 1 by small e of its original value. So mechanical energy, which can write it down here. By coming class in detail, I will explain you. Quality factor is also there. Only one slide is there. This one. Okay, but you need to know about that to DH later on course last slide. Is it clear?
It was clear, sir.
If you do the practice, you can easily understand that what I have been discussing in this. Okay, so చూస్తే మీకు తెలుస్తుంది.
Sir, I have created the group and given a request to you. Please join and share the material, sir.
Okay. I will convert the PPT. Shall I will convert it to the PDF so that you can follow the PPT.
Sir,
Yeah, tell me.
sir, the last time semester 1, when I write about surface integral as it is in the textbook, I didn't get full marks, I think. Because ఇప్పుడు సర్ఫేస్ ఇంటిగ్రల్ అని మనకి ఫస్ట్ సెమిస్టర్ ఫస్ట్ యూనిట్ లోనే ఉంది. సో అది
మనం ఏంటి వెక్టర్ అనాలిసిస్ లో ఉంటది, లైన్ ఇంటిగ్రల్, సర్ఫేస్ ఇంటిగ్రల్, వాల్యూమ్ ఇంటిగ్రల్.
సో సర్ఫేస్ ఇంటిగ్రల్ ఒక్కటే అడిగాడు, అది 10 మార్క్స్ కి అడిగాడు సార్. అంటే 4 into 10 కదా, 4 క్వశ్చన్స్ రాయాలి అక్కడ. సో దాంట్లో అడిగితే మనకి టెక్స్ట్ బుక్ లో ఉన్నదే 4 lines ఉంది దాని గురించి. సో నేను అదే రాసా, కానీ నాకు ఫుల్ మార్క్స్ రాలేదు అనుకుంటా, అందుకోసమే నాకు సి వచ్చింది సార్.
దట్స్ వాట్. అందుకే నేను ఏమంటున్నానంటే బెటర్ టు గో ఫర్ ది యూనిఫైడ్ ఫిజిక్స్, బెటర్ టు గో ఫర్ యూనిఫైడ్. సో ఇన్ అవర్ టెక్స్ట్ బుక్ ఓన్లీ సో మెనీ మనకి కొన్ని మిస్టేక్స్ ఉన్నాయి, ప్రింటింగ్ మిస్టేక్స్ ఉన్నాయి. బట్ ఎవరైతే రాసినారో మనం వాళ్ళని తప్పు పట్టదు, కానీ ప్రింటింగ్ మిస్టేక్స్ ఉన్నాయి. కాబట్టి
మీరు 10 మార్క్స్ ఇచ్చారు, 20 lines లో రాయాలి. ఇక్కడ ఉండేది 4 lines ఉంది సార్. 20 lines ఎట్లా రాసాను?
4 lines కి 10 marks ఎట్లా వేస్తారు చెప్పు నువ్వు?
మళ్ళీ అక్కడ ఉన్నది అంతే సార్ టెక్స్ట్ బుక్ లో.
మీరు అక్కడ ఉన్నది అంటే ఇక్కడ నువ్వు ఆ టెక్స్ట్ బుక్ లోదే నేను చదివి రాస్తానంటే కాదు కదా.
మన టెక్స్ట్ బుకే కదా సార్ ఇది.
మనదైనా కూడా అది 10 marks అంటే దాని నుంచి సంథింగ్ ఈస్ దేర్. ద ఎగ్జామినర్ ఈస్ గోయింగ్ టు ఎక్స్పెక్ట్ సంథింగ్ ఫ్రమ్ దట్ కాన్సెప్ట్, సంథింగ్ ఫ్రమ్ దట్ కాన్సెప్ట్. ఓకే, ఓన్లీ సర్ఫేస్ ఇంటిగ్రల్ ఇచ్చినాడు అంటే ఆ సర్ఫేస్ ఇంటిగ్రల్ కి సంబంధించి నీ కాన్సెప్ట్లు ఉన్నాయి అందులో.
దానిలో మిస్టేక్స్ ఉన్నాయి, ఇంకా డైరెక్ట్ స్టెప్స్ ఉన్నాయి.
అదే డైరెక్ట్ ఉన్నాయి, నేను అదే చెప్తున్నాను ఇక్కడ. బెటర్ టు గో ఫర్ యూనిఫైడ్ సో దట్ విల్ క్లారిఫై ఆల్ యువర్ డౌట్స్.
సో యూనిఫైడ్ ఫిజిక్స్ బై ఆర్పి గోయల్.
యా, యూనిఫైడ్ ఫిజిక్స్ గుప్తా అండ్ కుమార్. ఓకే సార్. యూనిఫైడ్ ఫిజిక్స్ పోండి, మీరు కోటిలో దొరుకుతాయి, హైదరాబాద్ హిమాలయ పబ్లిషింగ్ లో కూడా దొరుకుతాయి. ఫిజిక్స్ ఫస్ట్ ఓయూ సిలబస్ అని. ఓకేనా? By coming week we will discuss the remaining portion.
Hello.
Yeah, tell me.
సార్, నాకు మ్యాథ్స్ క్లాస్ ఉంటే మ్యాథ్స్ చూసాను. ఫిజిక్స్ క్లాస్ యూట్యూబ్ లో చూస్తుంటే నాకు లైవ్ రావట్లేదు. దాన్ని ఎలా మళ్ళీ ప్రీవియస్ నుండి చూడాలి సార్?
ఇది వీళ్ళు రికార్డింగ్ అయింది పెడతారు అనుకుంటామా, నీ క్లాసెస్ పెడతారు మీకు. ఇప్పుడు ఇది
లేదు
రికార్డింగ్ అవుతుంది, ఇది ఈ రికార్డింగ్ అయిన వీడియో మళ్ళీ
ఓకే.
అగైన్ దే ఆర్ గోయింగ్ టు బి పుటింగ్ ఇన్ యువర్ వెబ్సైట్, అంబేద్కర్ ఓపెన్ యూనివర్సిటీ వెబ్సైట్ లో దే విల్ కీప్.
నేను చెక్ చేశాను సార్, రాలేదు, అందుకనేసి మిమ్మల్ని అడుగుదామని మళ్ళీ మీటింగ్ లోకి వచ్చి.
ఓకే, యూ కెన్ జాయిన్ ఇన్ డైరెక్ట్లీ ఇన్ మన జూమ్ మీటింగ్ లో జాయిన్ అవ్వండి ఒకవేళ ఇఫ్ యూఆర్ ఫేసింగ్ ది
అంటే సార్ నాకు మ్యాథ్స్ ఫిజిక్స్ రెండు ఒకటే టైమింగ్ లో ఉన్నాయి.
రెండు ఒకటే అంటే థింక్
ఒకటే
ఒకసారి నేను
టైంలో
మాట్లాడతా మేడం, ఉషా మేడంతో
ఫిజిక్స్ రికార్డెడ్ వీడియో లేదు సార్,
అసలు రావట్లేదు.
అప్లోడ్ చేయలేదు.
నేను మాట్లాడతా, నేను మాట్లాడి వాట్సాప్ గ్రూప్ లో నేను పెడతాను, సరేనా?
సార్ నా నెంబర్ వాట్సాప్ లో లేదు.
ఈ ఎవరు కోనేజీ అడ్మిన్ కోనే?
Sir Vinod Misra.
యా షీ ఈస్ ఆస్కింగ్ టు జాయిన్ ఇన్ వాట్సాప్ గ్రూప్. యూ కెన్ టేక్ హర్ నెంబర్ సో దట్ యూ కెన్ యాడ్.
Okay, sir.
లింక్ ఆల్రెడీ ఇచ్చారు సార్, తను లింక్ క్లిక్ చేసి జాయిన్ అవ్వడమే.
అది ఒకసారి మీ ఫ్రెండ్ ఎవరో ఒకసారి చూడమ్మా, ఆమెకు పంపించేసి.
ఒకసారి నాకు పంపిస్తారా? నేను నెంబర్ చెప్తాను. హలో,
ఇక్కడే
హలో
చాట్ బాక్స్ లో ఉంటది, చాట్ బాక్స్ లో ఓపెన్ చేసి చూడండి.
4 లో చాట్ బాక్స్ ఓపెన్ చేస్తే వినోద్ కుమార్ అని ఉంటారు, ఆ లింక్ క్లిక్ చేస్తే జాయిన్ అవ్వచ్చు.
I just sent my
చాట్ వాట్సాప్ లో
WhatsApp
ఉంటుంది.
number again. Please send the hi message to that number. I will.
7019910348.
1 minute 00
7019
70
199
199
10348.
10348
This
70
group,
199 10348.
this
Okay.
group is for only for the benefit of the students which is related to physics subject. ఓకే,
Okay.
ఏ అదర్ ఏమి మెటీరియల్ మీరు ఏమి పెట్టొద్దు పర్సనల్ సంబంధించి ఏమి కూడా.
No, sir. I will delete anything
Okay.
extra. Only physics
అట్లయితే
and
ఎగ్జిట్
online
అవుతా,
classes.
ముందే చెప్తున్నా.
Yes, sir.
రైట్
Okay.
రైట్, ఆల్ ది
Thank
బెస్ట్. కమింగ్
థ్యాంక్ యూ
వీక్
సార్, థ్యాంక్ యూ.
రైట్
Thank you, sir.
రైట్
Thank you, sir.
థ్యాంక్ యూ సార్.
రైట్ రైట్.
థ్యాంక్ యూ సార్, థ్యాంక్ యూ.
థ్యాంక్ యూ సార్.
oscillation oscillators